the other day, which, let me see if I can find it, was probably, I'm not sure. Right. So I was going over the new FL Basic, and I think I wanted to mention, perhaps I already talked in some detail about the configuration file. So what I wanted to mention was mostly a couple of new things that are in there that weren't there before. So I'll focus a little bit on that. And if you have any specific questions about all of these that are not clear from the documentation or from these the descriptions in here, just let me know, or you can go ahead and ask me now. This would be a good time to go over more specific details. But other than that, these are pretty much the same thing that we saw before. I mean, for specifying functional structural data, you might you have some options for DICOMs. I'll mention some options for DICOMs that weren't there before. If you have DICOMs and they are all, and you put them into the scanner folder, into the subject-specific scanner folder, that's basically in here. You know, the blue is where you put your data. If you put your, sorry, can you hear me?
Can you share your screen?
Oh, right. I was pointing at things that nobody else was seeing. Sorry about that.
Yeah.
That's a good point. Thank you.
Okay,
let me see. Can you see my screen now?
Yes.
Yep.
Okay, so this is the blue are the things that you typically enter when you specify a new experiment and a new subject. And in this example, for the naming convention, I'm assuming that you have an experiment that is called example. That's the experiment code. And then the subjects are going to be called example 01, example 02, and so on. And in this case, we have a subject which is called example 01. So, and you specify all of these config files. Here is the config file that we are talking about, where you specify the source of your data. And typically, if you have Nifty files, you can specify the source of your Nifty files. Typically, you would put them in here just to have a place where you have the raw data that you got from the scanner. If you have raw data from the scanner already in DICOM format, you can run and you put it within this folder. Then you can, before running the import step, you can run this step that is called, let's see, what is this plain? Here you can run FL Basic, convert DICOM, and then the name of the subject. What that does is it takes everything that is within the scanner folder that is an actual DICOM file, and it reads them, and it tries to make sense of them, which is basically the.
Oh no.
Or something else, and everything is.
Yeah.
You're freezing in and out. So yeah, really.
There we go.
Okay, I'll continue. If this reiterates, I'll move to I'll connect through cable instead of the Wi-Fi thing. Okay, so if you have DICOM files, you can import them using this syntax, and that will convert everything to Nifty. And you will get files that are called run and a number within the same scanner folder. And the number is the DICOM run number, the DICOM session number, basically. And then you get a log file that specifies all of the details for each session. And this is also an automatic type of identification routine that tries to identify which ones are your functional data and which ones are anatomical data. And if it successfully finds them, then it will put them within folders that are called ANAT and FUNC within this scanner folder. And otherwise, it will give you a GUI to let you choose among all of your DICOM runs which ones are the ones that you care about. And that basically, sorry, go ahead.
Which tool is that using?
This is using SPM DICOM conversion, but it just has some wrapping around that too, because it also reads the header information and creates these JSON sidecars that are compatible with bits format. And the things that we care about the most are two information that is read from the DICOM automatically. One is the TR information, the repetition time, and that it comes from the DICOM headers, and it's put into the JSON repetition time field, and it's converted into seconds because in DICOMs it's always in milliseconds. And then the second thing is the slice timing. At least from Siemens machines, we are reading the slice timing information from the actual header file of the DICOMs, and we are converting that to a, I think, what was it called? It's called slice timing field in the JSON sidecar file, and that is useful for doing a slice timing correction because sometimes if you have like a multi-band acquisition, the timing are complex or you don't know exactly where was the exact order of the acquisition, so that is useful. And all of this is basically using SPN, DCM, DICOM conversion with utilities with some additional stuff to be able to interpret the header information properly and convert it to these JSON files. Well, I'm working on this. This is why I was asking you guys to give me a few examples to be able to do this automatic identification of the nature of each DICOM run a little bit more robust. Because currently it's kind of relying on the, I think it's called the image type subfield in the DICOM header that contains a bunch of things like primary, whether something is primary or secondary, whether something is, I don't know, a lot of this information. And some of that can be interpreted in order to identify uniquely which ones are your anatomical files and which ones are your functional files. But I'm still trying to, and also for the DTI data, I can also, I believe, identify it correctly. But for the field maps, I still don't have a good rule to identify them. So that's why I need more data to look at those examples.
So there's one piece of information also with the DTI data that's not normally unpacked, but I know what field number it is in terms of four number codes. Would that be helpful to have that? And then you could see whether, with what you've already set up, it would be possible to grab that from the header.
And what is the information that you think that it might be useful for this? Sorry?
It's something like echo time difference.
Echo time difference. Okay, let me see.
I'll look it up again and send you. I don't.
Okay.
Exactly, there's a few things that are named very similarly, and I got completely confused about them. So.
Cool. And if you have also some specific requests about what type of information you would like to have in these JSON files that might not be, that might be useful for DTI data, but it's not particularly useful for perhaps for functional data, because since I'm focusing on functional stuff, I might be missing something that you might want to have there. So let me know if there is anything that might be useful for your routines as well. And of course, you can use any other tool that if you want to convert them. I'm just trying to streamline everything as much as possible, and getting control of the DICOM to MNI conversion allows us to do all of these nice things that make which basically interprets information from DICOMs automatically, and the rest of the pipeline will use that information, so you don't have to figure out what that is about. Things like slice timing, all of those things that are typically difficult to figure out, like manually from the data. So okay, so that's the DICOM conversion, and once you have that's the only thing that was actually different from in this type of configuration files where you specify the functional data, structural data. You can also specify either don't specify anything and first import the data, and once you have imported data, it will be automatically placed into ANAT and func folders within this, and then you can specify that the functionals and structurals are going to be anything. For example, you can enter in the functional something like this, and if you have done the DICOM anatomical DICOM to NIfTI conversion and it worked fine, then it will be anything that is placed in the func folder that is called a NIfTI file will be your actual functional data. So that should work. You don't need to actually go and look for it. Assuming that it did work, and it didn't work and you have to specify them manually, then just specify them manually and specify the location of them. And in some other cases, you might not want to have them in those folders. You might want to import them from some or other place already in NIfTI format. So you in here just specify as always the location of your functionals and atomicals, and that's it. And the RT is one of the things also that changed before. If you don't want to specify and want it to be read from the anatomical data, from the functional data itself, from the header information, either leave this empty or set it to none, to not a number. So if you set it to none, it will be out, or just don't include that field. It will be attempted to be read automatically from the JSON sidecar. So this assumes that you have these JSON files that have a repetition time. If you don't have them, then specify here the TR as we've been doing so far. Okay. And that is basically everything is the same. Then for the design information, I was trying to go into a little bit more detail about these options that actually were already there before, but I didn't explain them in much detail before. So this is where you specify the onsets and durations of your conditions. So basically anything that is a condition for every event, you have an onset and a duration.
Alfonso, can you zoom in a little bit more on the?
Yeah, I think I can. Let me see if can you see the zoomed version?
No, but
Huh.
I think
On the upper left corner, if you change 100% to
Roland, please.
left. It's over by left of normal text.
Let me
Top.
see. What do you? I see it. I see it. Okay, let's try that.
That's
It's a little
lot
better.
Thank you.
Okay, so let me see. 200 perhaps is too much. Yeah, that's still reasonable. Yeah. Okay, so the unit sunset durations is the typical information that you enter for every event. You specify sunset and its duration, and then the different names of the different conditions that you specify. So you will have a onset will be a column, typically 2 columns of data. The first column contains the actual onset times in seconds, and the second column contains the number which specifies the number of the condition number. And then you specify give names to those conditions, to these condition numbers. And that's what typically you do. What you typically do in a standard scenario, if you want to do something a little bit more complex, like parametric modulations or other sort of non-parametric modulations and things like that, then you have all of these additional options. So let's say that you have also for each original event, you have some covariate that is basically one single value per event. So this is not like a covariate like a realignment parameter, which is a single value per scan. This is a covariate that is a single value per event. Event might be a block or might be an individual event or a trial, right? So everything that is a trial that you have specify an onset and a duration for it, you can also have an associated number for it, something like a response time or the jitter that happened in the scanner, or anything that it might be relevant and is a measure that has basically a single value for per trial.
So I had a quick question while we're on onset times. It's semi-related. Some of mine have negative onset times. That seems like an error. Can it handle those? Why are they happening? Like,
could be. I mean, it can handle negative onset times fine. Sometimes it happens if you remove the first few volumes from the data, from the functional data, and then perhaps the first trial in the actual experimental design happened before your first acquisition. So that would be a negative onset time. So that might not be an error. I mean, just make sure that they make sense and you have something like that. So
one other thing that might be is doing that slice timing correction where you need to adjust all of the event times by a certain amount to account for the within an actual volume acquisition you're correcting to.
Also, I feel like it's imperfect. That leads to my next question is how exact these have to be, because it is, I think, I'm getting imperfect numbers because I have the channels for the mic and the computer and the triggers. And it's Jen's code that's just basically data mining and looking for peaks. So if the trigger's off by a little bit, then it could be that those don't match up perfectly because they're different channels. So my question is also, since it's fMRI, it's not great, it's not too particular, but if I think like there's some variation of like half a second in my onset times for, from trial to trial that's supposed to be the same, or from experiment to experiment, like how perfect does that have to be? Since they're getting mined from a channel, they're just finding peaks on the channel. If they're off by like half a second, will that blow my analysis?
Are they short events, or is this like a fast event related design, or what type of design do you have?
I think it's median. I think it's repeating a visual cue. So like 5-second trials maybe?
5-second trials, so and the trials are separated by relatively long times or short times?
Fairly short for some of them.
Yeah, this is
repetition suppression.
And how long is the TR?
The TR is really long. It's like a 500-second TR or something.
TR?
Yeah, that's what's listed in the files I got from Jeremy Greenlee. I had never seen a TR like that, but.
Do you mean 500 milliseconds? Or?
Huh?
Do you mean 500 milliseconds?
No, I mean 500 seconds.
That doesn't make any sense.
That
No.
doesn't make any sense. Yeah, I'll check the notes again. Maybe they're mislabeled because these are from the files that we got from Greenlee's lab. It's like a Word document describing some stuff, but
Right.
like a single long acquisition, which
So that could be like the length of the session.
maybe, but
That
why
might
would
just
they
be
call it
mislabeled.
TR then? Yeah. Anyway, I'll talk with you offline if I can't figure
Sure.
it out.
And if not, we can just, if you have the DICOM sources, we can look at that information in the files themselves as well. So,
I know I have the Nifties. I can check to see if the DICOMs are still there.
well, there is almost nobody uses it. There is a field in the Nifties that encodes, that could encode TR, but no, I think very few software packages actually encode it. So it's probably not going to be there. But I don't know. We can take a look.
I think the DICOMs are still there somewhere.
Okay, but just to answer the original question, 0.5 milliseconds is not too long of an error as long as it's not consistent, and if it's just
Not
random.
0.5 milliseconds, 0.5 seconds.
Sorry, yes, 0.5 seconds. Yes, half a second is not terribly long. And one thing that you can do is specify this. I think it's by default like that, but let me check. When you run the first level analysis, the model estimation, you can specify that use this option that includes, in addition to the convolution with HRF, the convolution with the first order derivative of the HRF. And what that does is basically accommodate a little bit of errors in terms of the exact timing of the responses. And this is sometimes used just because the different areas of the brain might have different hemodynamic delays, and this helps correct for that. But also in your case, if these errors are happening just from the design estimation, that might also help you. But this assumes, this will correct for it, and it will not introduce biases as long as those errors are not consistent. If they are like related to your task, then you have that will be a problem. But if they are just random misspecifications, then that's perfectly fine.
Yeah.
I'm just kind of in the weeds here, so
Yeah.
like it. All right, thank you. That is
No problem.
comforting.
Okay, so let's see, where were we? Okay, so we were talking about if you have those covariates, you can specify a parametric modulation based on that. And let me just start with what parametric modulation is, just making the simplest case. Let's say that you want to modulate, the temporal modulation is done anatomically. So let's say that you want to estimate what is called the temporal modulation of your condition effects. What that is actually doing is trying to estimate whether the response is changing over time. So typically when you model your condition effects, you are modeling the effect size, basically the response to the Bolt signal associated with the presentation of one particular event type is modeled as a constant value, and that constant value is perhaps an increase in activation or a decrease in activation, but the model kind of assumes or tries to estimate a constant value across the entire run that represents how much the Bolt signal changes in the presence of your trial. Well, if that size of the response changes over time, that is not basically even modeled. It's not part of the model. So you can actually try to model that and see where the size of the responses to one particular trial or one particular condition changes over time within your session. So one way to do that, at least conceptually, would be to try to look at whether the size of the responses increase linearly or not, to do something like imagine something like a linear regression of the size of the responses. You could estimate the response for each trial separately and then do a linear regression of those values to estimate where those are changes. Or you can try to do that parametrically within the same model. So what you do is, instead of modeling just introducing into the first level design model just one single value that is going to estimate the actual constant size of the effect as a response of your condition, which is effectively modeling the size of the average response of the Bolt signal change in the presence of your condition. You can introduce two parameters in the model, one that models the average response and one that models a linear trend with time. So you can have a second parameter that, if it's positive, is modeling changes in activation as a response of your condition that increase in size with time, and if it's negative, it's going to be modeling things that decrease in time. So with those two parameters, you can model not only average or constant responses within your session, you can also model how that response to that individual condition is changing over time, at least in a linear manner. And if you want, conceptually, you could do it like in a parametric way using a higher order basis. You could use like a basis for linear, quadratic, and cubic terms if you want to model potential cubic third order changes in the temporal profile of the responses for one given condition. So what T-mode parameter actually does is estimate this first, well, all of these models, but initially just the simplest model, just modeling linear changes over time, over the length of the session of the responses associated with a given condition. And it allows you to specify that, just specifying whether you want to include temporal modulation or not for every condition. So if you have n conditions, let's see, I think I have this wrong. Let me check. This is an M condition. M is modulated by time because I'm calling M the number of conditions, and it's actually the number of onsets. So sorry about that. Let me change that. And this is also M because it's for every condition. Yep. And this is also M. Okay. So just for consistency, I'm calling M the number of conditions here and N the number of events that you get. So you have a matrix of N by 2, which are the onsets. And then the second column of the onsets have numbers that range from 1 to M. And that N is basically the number of different conditions that you have. Okay, so in T-mode, you can specify an array of zeros and ones. What you are saying with that is which ones among all of your conditions do you want to potentially model changes in time, linear changes in time within this session, as in the size of the responses to that particular condition. So if you have 4 conditions and you enter a 0001 value in T-mode, you are saying that the 4th condition you want to, in addition to model just a constant term of the response size to that condition, you also want to estimate potential changes in time for to the size of the response for that condition. And you can also enter numbers greater than 1 if you want to model this kind of higher order temporal changes. If you want to include quadratic terms or cubic terms, just enter 2 or 3 for that particular condition. And when you do that, you will get condition names that are named, if you name a condition speech and you enter temporal modulation, it will be called speech x time. So it's speech for times time, the name of the new condition that is automatically created for you that contains the parametric modulation effects of that particular condition. So in addition of getting a speech, when you define the contrast, remember that when you specify the designs, the first level design information, you can specify different contrasts, right? And for the, if I have an example, you can here you can specify a contrast that says speech 1, baseline 1. Well, if you, when defining this model, you included parametric terms for the speech condition, then you could specify something like this. I think it's called x time, and look at potential changes in the size of the response, basically in the slope of the changes in the speech, whether they are changing faster or slower than the size of the changes in your baseline condition. So that would be a way to look at how things are changing over time in the response time, the response to one particular condition, comparing 2 conditions actually to those effects. Okay, so this is what parametric temporal modulation does. And in addition to temporal modulation, you can specify any other arbitrary type of parametric modulation. So if you think of it, temporal modulation is just using, for every event, it's using a value, a number that corresponds to its own time, right? And those times are linearly increasing for every event, and you're trying to model where the response effect size of the pulse signal changes correlate with this covariate, with this time covariate for every event. So instead of using linear values that encode time, you could encode anything else. If you have a value that is response time or anything that is a different value for each covariate, you could use the same type of models, the same type of parametric modulations, but instead of using a covariate that encodes the actual time of each event, you can include a covariate that encodes anything that you specify, any user-defined covariate. And this is what, let me see, sorry, it's a little bit up. This is what this P-mode option allows you to do. In the simplest case, you can just have just as in T-mode, you will have a 1 row of values having a 1 or a 0, specifying whether you want to include parametric modulations for one particular condition. And then you just have to specify the P-mode values. Those are the same things that are, it's the same dimensionality. Oh, sorry, I got this wrong. This was actual, yeah, NK. PMOS names, those are, yeah. So this is for every onset, for every event, the same size of the onset matrix, you can specify a column of values that contain your, let's say, response time. And you enter that under PMOD values. And then those covariates, those are the things that will be entered as covariates in your parametric modulation if you use the PMOD option. So when you want to do parametric modulation, just specify the PMOD values here, basically the numbers for every event. And then you give names to those covariates, something like response time or whatever that covariate actually meant, and then include in PMOD to which particular conditions do you want that covariate to apply, for which conditions do you want to estimate the parametric modulation of that condition, of that covariate for that particular condition. That's how. Sure, go ahead.
If you wanna enter a nuisance covariate, would you need to specify that in the contrast?
Right, that's a good question. So some of these covariates might be something that you care about. So for example, temporal modulations, you might actually care about that, or you might not care about. And at this level of the specification, you don't actually care whether you care or not later. So in here, you're specifying anything that you want to include into your model. And then later on, when you specify the contrast, you can actually look at the things that is where you specify which things do you actually care about. So anything that you include in here is going to be entered as part of your design matrix, and it's going to get some regressor images that correspond to the size of those effects that you are modeling. But then you have to decide when you look at your contrast whether you actually care about those and you want to compare those values, or you just want to totally disregard them and not use them. When you don't use them, they are still being used for the first level estimation. So the first level estimation is still using those parametric effects as part of the first level design estimation of the effects. It's only that you are including the bus covariates of no interest. So if something is a covariate of no interest, enter it in here and then just forget about it. And if something is a covariate of interest, enter it here and then specify the particular contrast that you care about when you specify the contrast in the corresponding configuration file.
Great, thanks.
Okay, does this make sense so far, or do you have any other questions?
No.
Okay, and the last option is non-parametric modulation, and what this does is basically break it out into one separate effect for trial. So remember how I said that when you were looking at temporal changes, you could do it two ways. You could estimate one effect per trial and then do a linear regression across all of the trials and see whether those things are changing across time or not. Or you could do this parametric modulation where you actually include only an additional column for your design metrics and that actually explicitly models the linear changes that you're expecting to see. Well, you can actually also do non-parametric analysis, and you just for that you're going to get a different condition effectively for every individual trial. And then for those numbers, which are going to be, of course, very noisy, you do whatever you want with them in terms of when you specify the contrast or when you want to enter them into second level analysis, you can specify how you want to combine them. And for doing non-parametric modulation, all you have to specify is whether you actually want to break each particular condition into event-specific effects or not. If you enter a 1 for that particular condition in this list of zeros and ones, it will be broken down into event-specific responses. And if you enter a 0, it won't. That's what it is too.
Would that like severely cut down on your I guess I don't know if power is the right word, but
yes, those will be extremely noisy. So getting ball signal is very noisy, and it relies to a great extent in repetition to be able to get meaningful measures out of a scanner. When you do this thing, you get rid of all repetitions and you get a single number that tries to fit what is happening for that particular event at that particular time point. So that's going to be a very noisy measure. But that is sometimes something that you care about because you want to estimate, you want to use that for your second level analysis. For example, I don't know, people use it for what they are called beta correlation analysis, when they try to estimate correlation across different regions in the size of the responses to a given particular task. That is called beta correlation analysis. And it works this way. You estimate first non-parametric analysis for every individual event. And then instead of looking at those individual numbers, you're just looking at whether those numbers correlate between one region and another region. And those gives you informative measures. So yes, these are very noisy measures, but as long as the analysis that you're going to do with them take into account that these are very noisy measures, you're going to be fine. Any other questions?
Alfonso, I was wondering if this PMOD setup now gives us a way to deal with the S-rate study where we can just estimate the model once. So remember in that one we had a few different conditions where we wanted to, we just wanted to look at, I think, speech versus baseline, just without removing the effect of movement duration. But then when we looked at the individual conditions, we wanted to look at clear speech versus fast speech. We wanted to include the movement duration covariate. Is that a way to, does this provide a way to do that?
Right, definitely. It's actually the PMOD option. You could enter actually the durations as a parametric modulation, and then depending which zero level for that covariate you use, that will affect basically how you are controlling for it. I'll talk to you about the details of that later. But basically, the idea is that. Sorry, go ahead.
Well, I guess the issue though is that, like, when we look at speech minus baseline, it's a combination of all the other individual speech trials. So I guess we'd have to do some trickery, right, to get that to work, because you'd want to basically, there's some sort of trickery we'd have to do.
Right. I think the trick is mostly determining which one is the proper duration level that you want to compare against. I think basically to all of the conditions, so that all of them are compared to the same kind of baseline duration. If you don't want to affect the different durations of different conditions, so it depends whether you want to. But you have difference in the durations for every individual event, but you might also have difference in duration for different conditions. And whether you want to correct for that or not is where the trick arises. If you want to correct for that, then you want to use the same baseline level for all of the duration measures. So use raw duration measures so that they are compared at the zero level of that covariate. And if you don't want to control for that, then you want to center the duration measures separately for each condition. So instead of entering something like absolute duration measures, enter duration measures that are relative, so to the average value of the duration for each individual condition. And in that way, you can control for the difference in different events in the different durations for every event, but you are not correcting for potential difference across conditions in the average duration of every condition, for all the events within a condition. That makes sense?
Yeah, that makes sense. But I think what we just have to. Well, that's a specific thing, so we can talk more about that.
Right. We'll talk about more in detail, just in case I'm missing something. I'll just to make sure that we got it right. But yes, that functionality should be possible to implement just using parametric modulation analysis with what we have right now. We don't need anything else, I believe. Okay. So that was parametric modulation analysis and all of the non-parametric and temporal modulation analysis, which are all the things that I didn't mention about the first level design when you specify the design. How do you create all of these conditions? Then for the preprocessing pipeline, everything is pretty much the same. You have a lot of options that were exactly the same. There are only a few options that are new. Let me mention those that weren't there the first time that I talked to you about this. First, they are the surface level preprocessing steps. So there is one. I explicitly included preprocessing steps that deal with surface conversion just to make things easier for everybody. So now you can actually resample your data and convert a volume data into a surface data as a single preprocessing step. So you would use something like that, functional surface resample, and that assumes that your data is already co-registered, your functional and structural data, and it will just convert your functional data into Nifty files into a surf Nifty file that actually is resampled at the position of the cortical gray matter within for that particular subject. So this assumes that you have run your data through FreeSurfer, but if you have co-registered your data, then you can actually resample as part of one preprocessing step in here. And I'll show you a couple of examples. I created a couple of default pipelines in addition to the MNI preprocessing pipeline. I also created a surface space default preprocessing pipeline if you want to use it, and so you can use as reference to see how this is used. And then you can also do a smoothing on the surface as part of the preprocessing step. So this specify, in addition to the typical functional smoothing that is actually applies on the volume, you can also use this functional surface smooth step that smooths on the surface. So you can now specify all of these things as part of your preprocessing pipelines directly. So that this allows us to have one pipeline for M&A space analysis and one pipeline, for example, for surface-based analysis. That is very simple. And another thing that you can do that you couldn't do before is this functional label. You can assign labels to different stages of your data. So let me see if I have an example here just to see what it's perhaps simpler to say it with an example, but it's not. Yeah. So you can assign labels to, this is basically assigning a label to the original data, just saying that this is your original data, and then after you apply realignment and ART and normalization, then you apply a different label, and then you say this is going to be my M&A space data, and then you smooth the data and smooth it again, and then you say, well, I'm going to call this my smooth data. And this assigning a label is useful because then when you specify the design, the first level analysis, let's see if I have it in here. When you specify first level analysis estimation options, you can specify which data do you want to use. Do you want to use the smooth data, the raw data, the M&A space data, the original data, and use the labels that you created during the preprocessing steps. And this allows you to, well, preprocess different, so run different analysis for different steps of your data along a single preprocessing pipeline. So for a given pipeline, you can think of it as a sequence of steps. You don't have to just run a first level analysis on the end result of that pipeline. You can actually assign labels and look back in time at intermediate preprocessing steps, results of the intermediate preprocessing steps, and run analysis on those intermediate steps as well using this label functionality. Does this make sense?
I think so. And the label name is just when it says label as blank?
Right. I created a few default labels. If you want to label something totally different, just use functional label and then add something that says label and just give it a name, my own stuff.
That'll be really nice when you're looking back and like, what did I do on this analysis? Oh, that's right. It's all here in the config files.
If you have multiple labels, would you have
right? And if you have exactly, that's a good question. If you have multiple labels, let's say that I do multiple actual all of this, I do it like that, and use this. Then you can specify my own stuff. Step one, I don't know, give this my new stuff, and this is my really good stuff, good data. And this is just assign them as different labels in here, basically. And this has to match basically how many times you use the functional label field in here. Okay, let me just go back to that. But if you, for the labels that are most commonly used, which is you want to keep something, I have created this. I think the list of them, you can find them, the list of the ones that are created by default is, I think, let me see, it's in the help of FL, most likely, if I put it there already. Let me see if I did it. No, I didn't. Okay, I'll update this. There are a few, it's going to be here. So the ones that are created by default, it's not even updated here. Okay. So are this one, label as original, label as subject space, label as M&A space, label as surface space, and label as smooth. Those are the default labels that you can just use a single name for that step. And if you want to use your own labels, just use the general functional label stuff instead. And the reason why is that I have specific things for this is because I want to have a default preprocessing pipeline that I can use that uses this specific, don't worry about it. It's just, it seems somewhat redundant. You have a few labels that come by default and you can use this and other ones are not, but this is, I don't know, added functionality. Okay, so those, let me see, it was the new things in the preprocessing stuff is the surface sample, the surface smooth, the label, and I think everything else was in there. Yeah, I think everything else was already in there. I didn't add anything new from that time to now. And these are all of the specific options that you might want to use for any individual step. So if you are using ART, you can change the ART thresholds by using this. If you're using something like normalization, you can specify the anatomical voxel sizes of your results or when resampling. So all of these are specific to individual preprocessing steps. And you can use all of these fields to specify to change the default settings. Okay, in model estimation, I think everything is the same, except the only difference is in this contrast. Sorry. Oh, well, I added low-pass filtering, which wasn't there, and I also added the, I don't know why it's not in here. Yeah, it is functional label, the functional label field. So you can specify the label of the data that you want to use as source for your first analysis using labels that you use during preprocessing. And then also another option that wasn't there is the low-pass filter. You can low-pass filter. And this is just there because we really don't have any data so far. I think that is multi-band, but as this is becoming most useful, most common, what happens in multiband is that you can get rid of a lot of noise effects just by low-pass filtering the data, because the low-pass, like cardiac and respiratory effects, are happening at much higher frequencies than the typical things that you care about. So you can actually try to high-pass filter your data to get rid of those stuff. If you have a design that is that the main frequency that you care about is kind of below, I don't know, half a hertz, then respiratory effects are going to be around 0.5 hertz and cardiac effects are going to be around 1 hertz. So you can high-pass filter that amount of noise, and that improves the signal-to-noise ratio because it reduces for a lot of these physiological things that are the most dominant sources of noise, particularly for high TRs. If the higher your TR, the less that you care about machine noise, and the more you care about physiological noise, and that's why. And well, the higher the sampling rate, the higher the ability that you can get of getting rid of a lot of these effects just by filtering. So this is the option. It's by default, it's not using any low-pass filtering, but you can just change that and specify the value in hertz, in seconds of your threshold.
Alfonso?
Yeah, go ahead.
For the high-pass filtering, I recall at one point we had talked, you had mentioned that using a sparse design, you don't need to use a high-pass filter.
Right. If you have a sparse sampling design, then you shouldn't be using any filtering at all, mostly because the time information is not of your TR is typically not accurate as representing the actual sampling of your data. So any type of filtering operation that assumes that your data is actually a continuously equally sampled time series is not going to be valid. So you shouldn't be using any type of low-pass or high-pass filtering in those cases. Okay. And for that, use 0 seconds for low-pass filtering, and that will implement no low-pass filtering and just infinite value or just a high enough value for high-pass filtering, and that will skip the high-pass filtering step.
Oh, so I mean, can I just put INF?
Yes, because otherwise the default value of high-pass filtering, if you don't specify it, is the 128 seconds, which is the default in SPM for every analysis. So if you don't specify high-pass filtering, it's still going to be using this default value. So specify high-pass filtering and enter an infinite value. So INF, and that will work. Okay. Any other questions?
Sort of related. Is there any place that we need to specify whether the design is sparse or whether the acquisition is sparse or continuous?
Right. There is no way to specify it. And I don't think the only thing where it matters is in this filtering or not. But there is no way, our script doesn't use that information so far. So, okay. But it might use it in the future as soon as we start mixing it with connectivity analysis. So probably I will make that option.
Hello?
Hello, can you hear me? Jason, can you hear me?
Hello?
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 Sorry. I actually was off there for a bit too. Is Alfonso still off?
No.
Can you guys hear me okay? I think it was just Jason. I don't see Jason now, so he might have
Jason
lost him. Or perhaps he just lost the camera. Let me see.
I'm here. I just
okay.
turned the camera, but it does seem like there are some connection issues. So I'll try to deal with them in a way that doesn't completely stop the meeting next time.
Okay.
Carry on.
Let me turn on. No, I cannot because I have sharing. No. Okay. Can you hear me okay now?
Yep.
Yeah.
Jason, are you still there?
I'm still here.
Okay. So I'll continue. So any other questions you had? Sorry, I missed the question.
Oh, so the sparse versus continuous.
All right, the sparse sampling. So right now we don't have any place to specify that, and the scripts are not using that information. In the future, I'll probably add one place to specify it, because if we want to do connectivity analysis, that information is useful for COM to have. So I'll probably include it. So for now, just keep in mind that if you have a sparse sampling, skip all of these high pass filtering and low pass filtering options, and if you have a continuous acquisition, then you are allowed to kind of use these filtering options.
Cool.
Okay, so all of these are just in the same things that we had before. You specify the contrast and you specify the model basis and any covariates that you might want to have. I think let's see. I didn't change or add any options there, so those are pretty much common. And that's it. I mean, I have a few examples of configuration files that show you basically how those work in our system. Let me see if I don't have an actual graphical window, but I should have this. Let me see if it's still connected. No, this is not connected. So I'll just tell you what it is. In the software folder for FrankLab, you should have. Let me see. Well, I'll show you in my computer, and you should have something similar in there. In the software, this will be in project BUSP Lab Software FL. You should have this couple of example pipelines. They are the kind of like default pipelines to be used for M&A analysis, and this is the default pipeline if you want to use surface-based analysis. This is how they look. Basically, the M&A space looks like this. It looks like the one that we have before, only that we are adding a few labels in case, just to make it simpler, in case you want to run analysis on different versions of your process data. And then the surface-based analysis pipeline looks like one of the ones that we had before. Is assuming that you have field maps and you want to use some FART and field map and warp and field map correction, and it's using registering the functional data to your structural data, and then it's doing the surface resample to extract the functional data, the position of the cortical surface, and then it's smoothing a couple of smoothing steps just with it on the volumetric data to get minimally smooth data and also fully smooth surface level data, so you can run your first level analysis later on both versions of that. And I haven't fully tested, this is very new, I haven't fully tested all of these pipelines are surface level analysis. So if you try first surface level analysis, you will most likely run into bugs. So let me know those bugs and I'll try to clean them and make that work as soon as possible. So, but just be aware that hasn't been fully tested yet. So you're going to be running into some issues there. And then let me see if this died, but let me see if I connect again. Let me see. Can you see? No, let me see if I can switch my shared window to my second screen. So just 1 second. Okay. Can you see my screen now?
Yes.
Yep.
Okay. So you see a terminal. Just okay. This is just to show you when I see. Yeah, I'll try to make it bigger in a second. Let me see if I can project BUSP Lab FL. Okay, let me see if I can. Do you know how to make this properties bigger? The terminal.
Yeah, there's
Could be some options in here.
View maybe.
Reference terminal.
Yeah.
Or the other view.
Sorry, in view.
That's
one over.
window, yeah.
No, one.
Left?
Yeah, you're in window.
That could do it though.
No.
There's no zoom.
No, I think the zoom is just gonna make it bigger, but not. Yeah, I think I see what you mean. Pitch up. No.
Bigger default size, font size.
Bigger. Yeah, this is it. Okay.
Yay!
So let me just do that. Oops, not that. I have too many.
Nauseum.
Yeah. Okay, I'll just do it manually.
It's bigger each time eventually.
Customization.
Yeah, just look at
There's no
them.
actual right size. Those from teeny tiny to huge.
Okay, there it is. Can you see it reasonably well now?
Yeah.
A little. Do you want? Sounds like bigger would be better, so let's just continue doing that. Okay. Okay, so in here you have an example folder, an example original folder. The example original is meant to be an example of what you typically would have for a single initial experiment for a single data before running any FL basic scripts. So this is basically the blue portion of the thing that I showed before, basically what you have to enter, and this is supposed to create a code that is actually, it contains a simple, just run all. I think let me see if I remember, run all is an example of FL basic, just commands for preprocessing, import, and first level analysis for that particular subject. You don't need to create a particular script for that, but if you want, you can put it into code or use that example. Then you will have a configuration folder where you enter this is one sample configuration file per subject. In this case, I only have one subject, so just one configuration file. This is the examples for the design information of that particular experimental design. This is an example of first level estimation options, and this is an example of preprocessing pipeline options. So this is an example of what the typical state of what you will need to define in terms of configuration files for a new experiment or for a new subject. And then we also have a subfolder where you specify, you have just a scanner subfolder where in this case I enter Nifty files, where you have 5 Nifty files. This is structural data, and these are forward functional data. So this is an example of all that you need to have if you want to. Sorry, I have a little bit of feedback. So this is an example of what you will need to define for a new experiment, for a new subject. All that you need to enter to be able to run the FL basic commands. Enter the data in the example scanner folder, create the configuration files, and then you can just run the FL basic commands, the import, preprocessing. And when you do that, you should see something that is similar to example folder. See the example. So once you do that, you should have this derivatives folder that has all the. So this is everything that is created automatically by a folder in derivatives that contains the preprocessing results. Inside of that, we have the subject data, and side of that, the anatomical data, also the first level analysis, which in this case is speech. And then you have the first level analysis. So this is an example of the same example underscore original data that I entered, and I just run it through FL Basic using the four commands for preprocessing, importing, preprocessing, first level analysis, and quality assurance plus. So you can use this as a guideline or kind of like a reference when creating new experiments. You are unsure how to name things or how to create what information to place in every configuration file. You can use the example folders in here. The example and example original folders in here as a guideline for your analysis. Okay, and now I know that a few of you have already started trying to run the FL Basic commands, because I got some feedback of things when things didn't quite work, and that is helpful. Thank you very much to everyone that is helping me debug everything that is still not working properly there, but we are getting there. We are getting to a state that everything should be relatively smooth. So do you have any questions or any issues that you run when trying this analysis? Or do you have any questions or issues that you think you might get into when you try to run this analysis on your data sets?
I ran into an issue after the one that you fixed. Mm-hmm. Got past that step, but ran into another one. So when trying to run the first level analysis for the rhythm study, there was some some issue where it couldn't, what is it? There was an error, length of regressor is not commensurate with data points. Error of something.
Length of regressions. Let me see your configuration files just in case. This is the RAI experiment, right?
Yep.
Do you know for which subject was it?
So this was for sub-RY01, etc.
Okay, so this data. Okay, and this is when running first level analysis, right?
Yes. Yep. And I've been playing around with some of those things. So the yeah. So
it could be. Let me see. Do you have any?
Yeah.
Just check. So do you have any covariates, second level covariates that you define? Let me see, the first level speech. That is default, or is anything that is not default in the motion linear art? That is all default.
Yep.
Could you show me the actual error message? Do you have it in there?
Sure. I'm not hooked up to the Zoom session, so I can't.
All right. Well, then just read it. So what was? Let me see if I can.
So it says running fMRI model specification, and then it says failed fMRI model specification. Then it says error using SPM run. What's that? SPM run fMRI spec. Length of regressor is not commensurate with data points. In the file project BUSPLAB software SPM12. Well, I guess that's just where the SPM run fMRI spec function is located. Then it says the following modules do not run failed fMRI model specification.
That's weird. I cannot tell.
So the first thing I thought was that because there were 49 images, but I only had 48 time points that just began with scan 1. I just didn't do the 0. I thought that was okay originally, and I tried putting in the 0, and that didn't change anything.
Right, that shouldn't be an issue. So, because I mean that would mess up your timing information when specifying the design, but it shouldn't create a mismatch between the actual length of the. I mean that seems more related to the length of your functional data, not matching the length of the function. Did you apply any non-default preprocessing steps that perhaps? Let me see. No, that's all fine. Let me check again the functionals from 5.
That one's different just because I was trying to figure out if one.
Right, the full path stuff. Well, I cannot tell right now. I mean, send me an email with an error message and I'll look at it into more detail. I'll figure it out. It might be a bug in the code, or it might be just some misspecification in some of these files. So I'll try to figure it out. Just send me the actual error message if possible, and I'll let you know. Okay. Any other things that you might have run issues into issues, or that you are not unclear if you have anybody else that is planning to run the USFL basic and you haven't actually done so yet? Do you think you have a relatively clear idea how to do so, or do you have any questions to help you get started?
I at least know the next couple steps. Right now I'm sort of going as general as possible, and then I'll funnel down from there. But most
cool. And you also sent me. Excellent. And you also sent me a question about the spm.mat files, right? Whether you could use them or not for specifying the design information, right? So instead of using configuration files, you can actually specify spm.mat files if you have already created your first level analysis in SPM. The only problem why I don't, it's possible, I would recommend, really, I would prefer if you try to specify config files instead of using that, because that will allow us to have more freedom as to what things we enter into the first level analysis and what things we don't. Because when you are specifying a SPM.mat file in here, which you can do, it will basically import the entire design matrix. So you cannot do many changes to that. If you want to add like non-parametric analysis or temporal modulation, parametric modulation analysis, and things like that, you cannot do that because that requires being able to modify the design matrix. And that is only possible when you have information about the condition onsets, duration, and all of that stuff. So even though for a first run, I would say just go ahead and use the SPM.mat files just to make sure that everything runs. Then I would, if possible, try to convert that to create configuration files that contain the actual design information in your study, and because that will give you much more flexibility as to what things you can do with those analyses for when you get to the first level analysis. You'll have much more power to do different things and change how the type of first level design information that you want to include or not in your analysis. So yeah, if possible, so for now run with SPM, but if possible, change it at some future point to configuration files.
Okay. I've been making lots of configuration files, so let's hope they work.
Okay, cool.
This is just a general question that I can't remember if we talked about last time, and this is, I guess, for Jason and Alfonso, is so right now, Elaine and I and looks like Megan are all doing these analysis in the FL folder.
Mm-hmm.
Is that where you want, like in the BUSP lab FL? Is that where you want all of the analysis to be? Like, is this sort of bypassing the experiment folder?
Right. At some point, I mean, Jason, if you want to intercede, but we talk about that. At some point, we are probably going to try to merge this with our experiment folder. But at some point, we want to keep things also separate because we want to make sure that we know which part of the experiment folder contains data that has been run through this pipeline and which part doesn't. Okay. So until we figure out all of the potential glitches of merging the two things together, we are going to, I think it's best to keep them separate, but at some point we are going to just change that and merge it into that. So right now we have this thing. In here you have the FL folder, which is where everything is being placed. It's inside Project MB, BUSP Lab FL, and the reason why it's going there is because there is a soft link in here. In here, there is a repository subfolder that contains a link to where our data is. So at some point, I'll merge it and I'll change this link and I'll move this repository to be merged with our experiment folder. But for now, since we are testing things and since we want to kind of avoid potential issues with having the two things together in the same root, I think it's best to keep it separate. Jason, do you have any comments or suggestions on this?
That's fine.
Great.
That's fine. But I mean, we have it's so we may be that we're just gonna I mean, having them separate so that we know what's what will help. We just need to go back through the other stuff and get rid of what's redundant down the road.
Right. So, I mean, for now, this is going to be the location of it in the mid-future. I won't say near future, but in the mid-future, we'll figure out which place we want to put it and how to mix it with the current existing information in our experiment folder. And I'll try to do those changes in the background so you don't have to worry about that.
Okay, great.
If you create scripts that need to know the location of that, use, if possible, this link, because then I will only change this link and that will be automatically updated for you. So if possible, if you are just creating your own scripts and you need to actually know the location of your data, like the absolute location, use, if possible, this link instead. Point to Project BUSP Lab Software FL repository, and as long as you do that, when I change this soft link, it will automatically update everything. So you won't have to change your scripts when we change the location of the repository. Make sense?
Yep. And I had one more question regarding quality assurance annotations.
Right, you mentioned if it was possible to merge it. So the question, if I interpret correctly, was you were actually doing this preprocessing branch option to create a different branch from an existing one, right?
Well, no. So I had started going through all of the preprocessed data through the quality assurance plots and making annotations as I went along. I'd started that before we started this FL Basic pipeline, and so all of that is located in a different analysis folder in the experiment folder. And but now I want to
just port it. Yes, if you have them, just point me to where they are, and I'll move them to the appropriate location within the new structure, so that they are automatically read by you. Yes.
Okay. Because I added some more in the new structure. Will that?
Oh, okay. So that will include merging the two versions. So the annotations are basically text files that are associated. So I'll see if I can automatically merge them, and if not, I'll ask you how they should be paired.
Okay. All right.
Okay, so I think if possible, give it a try to running the analysis, and once you have a little bit more experience, the next meeting we'll probably sit down and go through any issues, errors, or additional questions. Once you start using it, we'll probably have more questions or more suggestions. If you have any along the way suggestions of how to organize things better or how to make things simpler for you guys, let me know. I mean, all of this is a work in progress, so I'm trying to make it as streamlined, as easy, and straightforward or intuitive to use as possible. So let me know if you have any suggestions how to make it better.
Great.
Fantastic. Thank you.
No problem. Thank you, guys.
Thanks a lot, Alfonso.
No problem. See you guys then.
All right, catch you later.